In Algebra 2, Section 3-4, we're dealing with a system of equations in 3 variables. So far you've been dealing with systems of inequalities, but now we're going back to system of equations. So basically we're dealing with lines that overlap, that intersect in order for us to find a solution. The catch is they've thrown in a third equation. So now if you can imagine just like the corner of your house where you have, the ones going left and right, and then, so this is a corner in your house, and then the wall comes up. So that is a 3-dimension, okay? So we have an X and a Y, which is your basic 2D graph, and then you flatten it, and out of the origin then comes also a Z coordinate. And that Z coordinate then makes it 3-dimensional. And a solution of a system of equations in 3 variables is called an ordered triple. You'll have 3, coordinates, one for the X, one for the Y, and for the Z, and it's called an ordered triple. So our steps are, we're going to take 2 equations at a time. So you're going to be given 3 equations, and our goal is the same as 2 equations. We're trying to eliminate variables. We're just going to have to do more work in eliminating the variables to get it where we can solve, and then we're going to plug back in. All right? So we're going to take 2 equations at a time. We're going to eliminate the same variable using elimination. So that's why elimination is an essential one. Eliminate another variable after you've narrowed it down to 2 variables. Then, once you narrow it down to 1, you solve. Once you've solved, then you plug in that to equations that you found in, not the original, because the original still has 3 missing, but you plug it into the ones you found in number 3, because that only has 2 variables. Then that eliminates one then that gives you the answer to the second variable, and then once you have 2 variables, you can plug it into the original. That's a lot of words, but let's go through an example, and it's not too much more difficult than what you're used to in systems of equations with 2 variables. So, in this case, this is what we're dealing with. I know, overwhelming at first, but we can do this. What we're going to do is we're going to focus on eliminating one variable, okay? Let's focus on eliminating x, right? By the way, if there's a letter missing, for example, if there's no x here, I would put 0x, because anything times 0 is still 0. So I have to make sure all the variables are there in the beginning. Even if they don't, I'm going to assign it 0 as its coefficient. So I'm going to take the first 2. 5x plus 3y plus 2z. So my first step is to take 2 equations at a time. Okay? 2z equals, we have 5x plus 3y plus 2z equals 2, and then 2x plus y minus z equals 5. I'm going to put a 1 in front of each of these to make things easier for myself. All right, so I'm going to work, let's say, on getting rid of, because these are 1s, I'm gonna get rid of my z's. That seems like the easiest. So this one, the only thing I need to do to get rid of my z's is to multiply this by 2. Right? This can keep going, because if I multiply this by 2, I end up with negative 2z. Positive 2, I add them, they cancel out. So I don't need to do anything here. Less work. And then I do 2 times this, which is 4x. 2 times positive 1, which is plus 2y. And then 2 times negative 1, which is negative 2z equals 2 times. Don't forget that. A lot of people forget the one on the other side of the equal sign. You have to multiply that too. 10. And then I'm going to add. Please make sure that you put in parentheses if you're adding or subtracting, just so you can keep things organized, because sometimes people forget, So let's see what we get. 5x minus 4x, which gives us just x. Sorry, I'm adding, my bad. So 9x 3 plus 2 is positive 5y. Don't have floating numbers here. I need to separate it with plus or minus. And then positive 2 plus negative 2, this cancels out. 2 plus 10 gives me 12, right? So now I have a system of 2 variables. I need to get another one in order to then eliminate another variable. So then I'm going to take, it doesn't matter which one, I can take, I just have to take two of not the same. So I can't take these two again, but I can take this and this, or this and this. So I'm going to take the middle two. So it's going to be 2x plus y minus z equals 5. And then 1x plus, I'm going to put 1. 1x plus 4y plus 2z equals 16. Now, here's the thing. I have to now get rid of to z also. Okay? Lucky for me, just like this one, I don't have to multiply both equations. I just have to multiply this by 2, which will give me this a negative 2, and this positive 2 will cancel out. So I just have to, this one I can just carry over, and this one I multiply by 2. So 2 times 2 gives me 4x. 2 times negative 1y is positive 2y. And then 2 times, not negative 1, just 1y. And then negative 1z is negative 2z. And then 2 times 5 is equals 10. This one I just bring through, plus 4y plus 2z equals 16. And because these are opposites, I'm going to add. So 4 plus 1 is 5x. 2 plus 4 is positive 6y. Negative 2, positive 2 cancels out, and I end up with 10 plus 16 equals 26. Right? So what happens here is then I have these equations. 9x plus 5y equals 12. And then 5x plus 6y equals 26. Now that I have here, this is my second step. Right, I'm looking down here. So we took 2 equations at a time, then we eliminated the same variable using elimination for the second one. And then now, number 3, I'm going to use elimination to eliminate yet another one so that I can solve for the final one. All right, I'm going to bring this back, but go ahead and pause and write this down for now. Okay, so now we're going to do the same thing. I'm going to get rid of, I'm going to do 5y. So I have to multiply this by 6 and multiply this by a negative 5. Okay? So 6 times 9 is 54x. 6 times 5 is plus 30y. 6 times 12 is 672. I should know this. Yes. Equals 72. Then we do negative 5. You could do positive 5 and subtract, but I'm going to do negative because I like adding. So negative 5 times 5 is negative 25x. And then negative 5 times 6 is negative 30y. And negative 5 times 26 is negative 130. So then, just like the other one, I'm going to add. Negative 54 minus 25, plus negative 25, which gives me positive 29x. Positive 30 minus 30 cancel out, and I end up with 72 plus a negative 130, negative 58, right? My next step, it says here, on step 4 is to solve. So now that I've narrowed it down to just one variable, then I can just solve like I regularly would by isolating the variable. So number 4 is telling me to solve by isolating the variable, and all I need to do is divide both sides by 29. This cancels out. Just give me 2. Yeah, should be able to do that. X equals -2, right? So now I have one variable. Now I can start plugging in. So step number 5, you should already have in your paper, says plug in variable to equation from number 3. So I'm going to plug in x equals -2, but I'm not going to plug it into my original equation, okay, because if I plug in x here, I still have y and z missing. What I'm going to do is I'm going to plug it into one of these that have only 2. Which one does, because I didn't change the value of these equations, I just rearranged them and manipulated them so they're still balanced, the same balance as this, so I can use them to help me get as a stepping stone to my original. So I'm going to choose, it doesn't matter which one, I'm going to choose this one, 5x plus 6, so this one right here. 5x plus 6y equals 26, and I'm going to plug in x. So 5 times -2 plus 6y equals 26. This gives me -10 plus 6y equals 26. Add 10 to both sides. And I end up with 6y equals 36. Okay? Divide both sides by 6. I end up with y equals 6. Now I have 2 variables. Because I have 2 variables already solved, my last step just tells me to plug in my x and my y to an original equation. So let's choose an original equation. I'm thinking the easiest one could be this one right here, or even this one. Oh, let's do the middle one. 2x plus y minus z equals 5. So we already have x, we already have y. Now all we need is to solve for z. So 2 times -2 plus 6, sorry about that, minus z equals 5. Now I only have one variable and I can solve. This is -4 plus 6 minus z equals 5. This becomes +2 minus z equals 5. I'm going to subtract 2 from both sides. I end up with -z equals 3. Then divide by -1. I end up with z equals -3. And here is my third variable. A lot of work, but it's not anything that you haven't done before. It's just, you know, these problems are a lot longer. You won't be assigned a lot of them, so it's very, very important that you don't, that you make sure you're not making any small math mistakes. So our order triple is x, y, z, which is -2, comma 6, comma -3. And this is our answer. That means if I plug this in to our original equation here, okay, then that means if I plug in it to each of these, it would give me these values. So go ahead and pause, write this down, right? And then go ahead and try page 165, number 2. Page 165, number 2. And I will see you in class.